In this video, we are going to start graphing quadratic equations. A lot of this is going to be review from Algebra 1, but we have a couple extra things we're going to do now in Algebra 2. So first, recall from Algebra 1 the different types of forms you could have. You could have standard form, vertex form. We called it in Algebra 1 factored form, but the better name is intercept form. Those are the three formats you're going to see. They tell us slightly different things, but when you're graphing, you're always going to need at least 5 ordered pairs. The thing that most of you probably did not see in Algebra 1 was the parent function. The parent function is the most simple version of a function. There's a parent function for linear, for quadratic, cubic, quartic, all the different exponents. And we're going to use it to speed up the graphing process for things that aren't quite as simple. So I'm going to fill out this first table first. If I have the parent function of y equals x squared, or sometimes f of x equals x squared, depending on how things are written. Remember, y and f of x are essentially interchangeable. If I plug in x is 0, I get y is 0. If I plug x is 1, 1 squared is 1. If I plugged in negative 1 squared is still 1 for my y. If I plugged in 2, I'd get 4, and negative 2, I'd get 4. That's very, very quick and easy because all I had to do was square a number, and I picked numbers that are pretty small. I'm going to use that in a little bit to make graphing something more complicated a little bit easier. But like it says here, when in doubt, you can always make a table of values to help graph any function. Even if you don't remember the parent function, you start picking numbers for x, plugging them in, it will give you a y value, put it on the graph. Eventually, you should be able to see a rough shape of the function itself. Maybe it takes you 6 dots, maybe it takes you 60 dots, maybe it takes you 3 dots. It kind of all depends on what x values you pick. But the overall process for graphing is you are going to identify the vertex of the parabola. This is your maximum or minimum. Oops, thought I had a pen, not a highlighter. All right, maximum would be if the parabola opens down. My iPad screen is going crazy today, I apologize. Minimum would be if parabola is opening up. Then to use the parent function idea, we're going to treat that origin or that vertex as the origin, but in quotes, it's not actually the origin. Then we're going to make a table similar to the one we just did, and we're going to graph the points based off of the vertex being our origin, which is confusing and it'll be a little bit clearer once we actually do it. Once you get your 5 dots, connect the dots. So number 12 here says graph the following equation given in standard form. First, we have to find the vertex. That's the hardest part. In standard form, to find our vertex, we're going to do negative b over 2a, okay? In this case, my a value is 3, b is negative 6, and c is 1. I don't really care about c here, but c is 1. So x equals negative 6 over 2 times 3. That's 6 over 6. X equals 1. X equals 1 is where my vertex is horizontally, but not vertically. So I now need to plug in x equals 1. So y is equal to 3 times 1 squared minus 6 times 1 plus 1. I'm not doing this in the table. I'm just kind of doing this off to the side somewhere. 3 times 1 squared is 3. Minus 6 times 1 is minus 6 plus 1. It gives me a y value. Well, 3 minus 6 is negative 3 plus 1. Gives me negative 2. So 1, negative 2 is my vertex. That is now supposed to be the hardest part of the rest of the problem. Because what I'm going to do, notice we have x, y, a, y this time instead of x, y. My a value is 3. My y value is just like my parent function, x squared. So what I'm going to do is I'm going to pick values of x, and I'm going to pick very, very specific values of x. I'm going to pick negative 1 and 1, negative 2, and 2. When I plug in negative 1 and square it, I get positive 1. When I plug in 1 and square it, I get positive 1. I picked those two numbers specifically because they are going to give me the same y value. And now I'm going to take that y value times the 3 that our a is. That's going to give me a 3 for both of them. Now, from my ordered pair that I already have on my graph. I get to ignore this middle column. From that red dot, I'm going to go left 1, up 3. Left 1, up 3. I'm also going to go right 1, up 3 from that red dot. That gives me 2 more dots very quickly. Now, for the -2, squared, I get 4. +2 squared is also 4. Multiply it by 3. That gives me a 12 and a 12. Again, ignore that middle 4. From the red dot, I can go left 2, up 12. Well, that brings me all the way up here. Go right 2 from the red dot, up 12. There are my 5 dots. Now I connect them, making sure that since this is a parabola, it should be curved. I don't expect perfection, especially on one that's kind of tight like this, but it should look like that. If you're like, I'm not really sure how that AY stuff works, you can just make a regular table, because 212 is not one of my ordered pairs. 1-3 is not one of my ordered pairs. It's an ordered pair based off of the origin. Okay, it speeds up the process, but it takes a little bit of extra outside the box thinking. If I want to, I could double check here, say, well, 0-1 is this ordered pair right there. 0-1 is what I got when I went left 1, up 3 from that red dot. If I plug this in, I should get a true statement. Well, 1 on the left stays 1. 3 times 0 is 0. 6 times 0 is 0. 0 minus 0 is 0, plus 1. That is a true statement. That is one of my answers. Now, it's not a solution because it's not telling us where that equation is going to equal 0. That's a different nuance thing. But it gives me my graph quite nicely. Where it speeds up even more is this table is almost identical every single question. I'm going to pick -1, 1, -2, 2 for x every time. Square it. I know that that's going to be 1, 1, 4, 4 every time. Multiplying by a is the only new number. I'm taking advantage of the fact that parabolas are symmetric. That's why I went -1, 1. 1 left, 1 right. 2 left, 2 right. They're being symmetric. If we remember from Algebra 1, we have what's called the axis of symmetry, which is where the vertex will always fall on, and then it should be mirrored left and right. Now, just as a reminder from our first chapter, we still have to identify domain and range every now and again. Domain is all of the x numbers that can work. In this problem, if I look at my parabola, it's not a perfectly drawn parabola, but the arrows are flared slightly outwards. I can continue picking x values to the right. I can continue picking x values to the left. X is an element of the real numbers. Okay, any x value works in this problem. My y values, range is what y values. Some of us like to just say y exists in the reals, which is true, but it's not the best answer. My lowest y value is my vertex. This is a minimum. My y value was a -2, and then everything above that is where those arrows are going to point. So y is greater than or equal to -2. That is my range. If you forget this part, I'm not going to be upset at all. If you forget this part, I am going to be upset. That is the thing that I need to specifically see for your range. It's a y less than or equal to, greater than or equal to a specific number. Have a great day, everybody.